Hello everyone, my name is Hark Chada, and I hope you are having a beautiful evening. Our story today focuses on tackling a critical business question. Where and how do we strategically deploy trailers to increase revenue and lower costs in the freight industry? Misallocation of inventory leads to unmet demand and higher operational costs. Our team focuses on answering this critical business question in a three-stage methodology. First is demand forecasting, then network allocations, finally, trailer relocation. The data is coming from three sources. First is freight demand index data to indicate where the demand is going to be. Second is network location data to classify these network locations. Finally, telematics data is used to accurately pinpoint the locations of trailers in real time. Now we're going to Elsa, reporter Elsa, with her boots on the ground to talk about demand forecasting.
In stage 1, the focus is on estimating the demand for trailers in each city using a refined version of the freight market index. The team employs a weighted geometric mean to blend recent data points, a method that gives extra importance to the most current trends while still accounting for historical data. This approach is particularly effective at capturing short-term volatility, ensuring that sudden changes in the market are reflected in the demand forecast. By translating these refined market indices into daily revenue and cost tiers, the team can accurately determine how many trailers each city truly requires at any given time. This nuanced demand forecasting ensures that trailer allocation is both responsive and economical sound, reducing the risk of over or under supplying a particular area.
Next, we turn to stage 2.
Thank you for that, Hark. In stage 2, we strategically assign trailers among dealers and company rented locations within a particular city. The team first identifies a central point, or a centroid, for each city, which is determined based on revenue potential. This centroid serves as the anchor for the allocation process. From this point, dealer locations within a 25-mile radius are given priority, ensuring that high-demand areas are covered first. The rationale is to use existing dealer networks effectively before turning to company-rented sites. Finally, should there still be unmet demand, the allocation extends beyond the 25-mile radius, focusing solely on the nearest locations to fill the gap. This approach not only maximizes coverage, but also ensures cost effectiveness. We implemented these allocation rules using Python libraries and Google API. We will now look at a short demo video by reporter Liana. You can scan the QR code on the screen to have a view on your own mobile devices.
This interactive map shows trailer allocations using synthetic data. Blue markers are dealer locations, green markers are company-owned sites, and red markers are city centers. In this demo, all trailers are assigned to dealers. Here's Indianapolis, where we can meet each other soon. Clicking on marker shows details, and zooming in reveals blue lines showing straight line distances to city centers.
Finally, we'll hand it over to our reporter Rupali to discuss stage 3, trailer relocation logic.
So for the trailer relocation logic, we wanted to move the trailers from their current location to their ideal location in a way that minimizes costs for the company. We first calculated the required distances and then used a linear program with the objective function to minimize the total distance traveled by all trailers. The objective function was subject to two constraints. Firstly, that all trailers are assigned to at most one location, and that each location receives its required number of trailers. This step closes the loop by merging demand expectations with actual trailer movements and assigning trailers to their ideal locations in a way that minimizes driving miles.
In summary, this innovative project provides a comprehensive framework for optimizing trailer allocation in the freight industry. By combining detailed demand forecasting, strategic network allocations, and efficient trailer relocation, companies can now identify the optimal cities to target, the exact number of trailers to deploy, and significantly reduce the pervasive empty mile problem. Financial comparison charts included in the project clearly determine the balance between tapping into high revenue, high demand centers, while managing operating costs efficiently. How wonderful.